Okay, so we're going to go through verification. Now, every year you'll be sending this kit back to us for a full, complete service and calibration and extended warranty. Now that's fine, we'll do that every year. However, I want you, the users, to be confident that the number that is produced out of this device is accurate and you're content and happy to write these numbers down. So to do that, I want you to verify these units, and it's very, very straightforward. First of all, what I've done is connected the battery. We've got lots and lots of juice in there, so we're happy with the power going to the unit. Okay, so now we will connect the sensor, and remember it's at 3 o'clock. So all we need to do is push it in and turn it. Dead straightforward and very, very easy. One of the biggest issues we have with users is they're not sure of how these goes in, and so they'll force it. And in that case, you'll bend the pins, you'll break the pins, you'll break the connection, and then you've not got the device. So again, very straightforward, just push it in and turn, off we go. And now the battery's plugged in and the sensor's plugged in, what we could do now is the LED display. So again, it's the middle gland, and all we're doing is just pushing it in and just turning it tight. That's it, nothing too heavy. So we've got the LED display, the battery, we've got the sensor plugged in. Okay, so what we can do now is turn the LED display on. So now it gets the flow cell, it's all tightly put together. If we close off this white bleed valve, that shuts off the drain. So now nothing's going to come out of the drain. However, we can still have bits coming out of the inlet. So we're going to put our finger over the inlet. Now this is non-formazine turbidity standard. This one is 10 NTU, and NTU stands for nephemetric turbidity units, for those who don't know. So we're using 10 NTU on a 0 to 20 range sensor, and the reason for that is we will get more accurate numbers further up the linear scale. So if you show a 0 to 20 range sensor a 5 or a 10 NTU standard, you'll get a good idea of its accuracy, and we'll always say plus or minus 10%. So if we put a 10 NTU standard in and it reads anywhere between 9 and 11, then we're happy. You have to appreciate that the accuracy on any instrument is plus or minus a number, and this number is 1% on this particular instrument. So on a 0 to 20 range sensor, it's plus or minus 1%, which is 0.2. So if you're using this unit and it's reading 0.01, well, that's anywhere up to 0.2 if this range of sensor is being used. Okay, so take the lid off the standard, make sure it's in date of course. We have closed the outlet, we're putting our finger or thumb over the inlet, and we're going to pour the standard all the way to the top, and we're going to get rid of these little bubbles, because these bubbles will mean something in terms of the numbers. Just get it right to the top there. We're going to put the lid back on, and when we tighten this up, what you'll find is it's creating a partial vacuum within the flow cell. Nice and tight, a little bit should come out, like so. Now, we could hold it for plenty of time, but more better than that, just prop it up somewhere vertical, and make sure that the sensor is pointing the sky. So we've put the standard, the non-formazine standard, into the turbidity flow cell, and we've kept it submersed, and we're at 10.9 NTU, so it's within the 10% pass value. So we're happy with that unit, and this is something I'd like you to do quite often, because don't just believe that the calibration cert is always accurate. Make sure that the turbidity sensor is nice and clean. And by putting a non-formazine standard in there, you'll be able to do your own checks, so you're confident that when you go out and deploy these, the data you do get while it's deployed is all accurate. Or else it's pointless, you're actually doing the work.